going to continue our lesson from yesterday, solving two-step equations. So I hope you wear your boots because we're going to do the two-step. Who can tell me how we start this type of a problem? Oakley. We're going to circle best friends. How do we know that they're best friends? Maddie? They're stuck like glue. Stuck like glue. Nadia, in example 7, which ones would you think are best friends? This is a little different than what we did yesterday.
X over 3.
X over 3. Now technically they're not stuck together with multiplication, but they are stuck together because of that division bar. So from here on out, it's going to be the exact same thing. I'm going to cover it up. I'm going to say, baby bear, what do you see?
I see a positive.
Very good. We see a plus 11. How do we get rid of that, Ethan? How do we get rid of plus 11?
You have to subtract.
Yeah, we're going to subtract 11 from
Both sides.
both sides. Why do we have to do it to both sides, ladies and gentlemen? We got to stay balanced, right?
Yes.
Okay. Now, what do we know about additive inverses? They cancel out and give us a value of
0.
So what is the only thing left on this side?
X
X over 3. Awesome job. And this side, you should know it, but you're allowed to use a calculator. 16 minus 11.
Positive 5.
Very good. Now, what is being done to the variable, Dylan? What is being done to X here?
Dividing it.
You're dividing by 3. So, Brody, how do I get rid of dividing by 3? Wait, Brody knows. How do I get X by itself? Help him out, Mason. Ethan.
Do the inverse.
You do the inverse, which would be what in this case?
Multiplication.
Oh, hold on. Ethan's going to tell
3
me, but
over
thank
X.
you. What am I going to multiply both sides by?
3 over X.
3 over 1.
Oh.
What do we know about multiplicative inverses, ladies and gentlemen?
They cancel out.
Great job. They cancel out, leave me with a value of 1x. But 1 is the multiplicative identity, so what are we left with over here?
X.
X. X equals?
15.
Awesome. Are we finished?
No, just do a check.
Yeah, in order to prove that we're right, we're going to check it. To check, what property do we use? Substitution. I'm going to write down the equation, and then I'm going to rewrite it asking a question. I'm going to ask, is 15 divided by 3 plus 11 really equal to 16? When I'm checking an equation, what do I have to follow, Emma? What rule do we follow when we're checking? Go ahead.
PEMDAS.
PEMDAS. Very good. We follow order of operations when we're checking it. So, what do we do first when we're checking this problem?
Divide.
We're going to do the division part. 15 divided by 3, class?
5.
5 plus 11. Is that really equal to 16?
Yes.
Yes, it is. So, 16 equals 16. Therefore, it checks. What's our solution?
X equals 15.
Very good. You may copy this down, Bubbles. I'm going to go ahead and put up the next question in just a moment, and I want you to try it on your own. It's very similar to this one. You're going to start it the same way. You can go ahead and pause it while they're working. Ready? Okay, question number 8. Don't write this down yet. Let's talk about this problem. What's different about problem 8? Who can tell me what's different? Miss Nadia.
There's double signs.
There's double signs. You see it?
Yeah.
So when we have double signs, what do we need to do, ladies and gentlemen?
Rewrite it.
We've got to rewrite it. So I like to write that in our notes to remind us if we see something like this later on what to do. So we're going to rewrite it because of double signs. What helps us to rewrite this, ladies and gentlemen?
Multiplication.
Multiplication, man. So when I've got two signs stuck together like this, how do I rewrite that problem?
You use multiplication man and a negative plus negative equals a positive.
Okay, but I don't have a negative. What you said is correct, but not on this problem. What do I do on this one? A negative and a negative.
is a positive.
There you go. So 7n plus 16 equals 100. Who can tell me what to do next?
Minus 16 on both sides.
Mathematically, that's correct, but I want to put those little tricks in that help us.
I will circle the best.
Let's circle best friends, just as a reminder. Whom are best friends here? Yeah, because they're stuck black glue. Stuck black glue. Now we're going to build the wall. Cover up best friends. And now, mathematically, what do we do?
Minus 16 on both sides.
Why do we do it to both sides?
It's called balance.
Are you with me? I hope so. So we're going to subtract 16 from both sides. What are these two numbers called?
Added, multiple.
No, you're right. Additive inverses. And what do we know about additive inverses?
They cancel out.
They cancel out and give us a value of
Zero.
zero. But 7n plus 0 is just
7.
awesome job. So we've got 7n equals, what's 100 minus 16? You get to use your calculator. What's 100?
84.
I heard 94, I heard 84.
84.
84 is the correct answer. Now, 7n, this is like what we were doing last week. 7n is just a one-step equation. What do I do now? What am I going to do to both sides?
You're gonna subtract.
Look, they're stuck like glue.
Multiply.
Go ahead. We're going to divide both sides by what? 7. We're going to divide both sides by 7 because that is the multiplicative inverse. What value do we get when we take 7 divided by 7?
1.
And 1 is your multiplicative identity, so what are we left with right here? N equals, use your calculator, you should know it, but what is 84 divided by 7?
12.
12. Are we finished?
No,
We have to check it. So when we check it, what do we do? What do we do when we check it?
plug it in.
We're going to substitute, plug it in. Some people call it the Glade method. We're going to write down our equation exactly like it started. I'm going to substitute in, excuse me, I'm going to substitute in what?
12.
12. When I check, I'm asking a question, kind of running out of room over here. I ask a question, is it true? When I'm checking and I plug it in, we have to follow PEMDAS. Awesome. It's our checklist. We have no parentheses that group. We have no exponents. So mathematically, what do we do first? Multiplication. 7 times 12?
84.
84. Minus negative 16.
60.
Does that truly equal 100?
Yes.
Do I need to rewrite this or can I put this directly in my calculator? You can put it directly in your calculator. And that's what I want you to do right now to practice using these integers. 84 minus 16 negative. It does give 100. And the reason being is we would have KO'd that and it become an addition problem. Does anybody have any questions about this equation? You may copy it down, Bubbles. All right, ladies and gentlemen, number 9. This is a two-step equation. We're going to start it by circling best friends. In this example, who do you think are best friends?
M over 11.
Yeah, M over what?
Negative 11.
Negative 11. Remember, the sign's so important? That's right. We don't want to lose the sign. I saw the sign, and we've got to make sure that we keep it. I'm touching that, I guess. We're going to circle M over negative 11. I'm going to cover that up. Make sure you're paying close attention. Baby bear, what do you see?
I see a
Positive
positive
one.
1.
How do we get rid of that plus 1?
Minus
Minus 1 on both sides.
Yeah, we're going to build the wall, and we're going to subtract 1 from both sides. We do it to both sides to stay balanced. Thank you. Additive inverses cancel out and give me a value of 0. 0 is your additive identity, so what is the only thing left over here?
M divided by negative 11.
Very good. M over negative 11 equals, you get to use a calculator, negative 10 minus 1. Mason, I'm going to let you help me. Negative 10 minus 1. You get to use your calculator, buddy.
11.
How about trying it in your calculator, just to be on the safe side, okay? Negative 10 minus 1.
9.
You put in your calculator 10 negative minus 1.
That's That's what I thought.
Help him out, please.
-11.
It's -11. Am I finished with this problem?
No.
No. I need you to make sure you're paying attention, okay? Because you're going to have an assignment in a few minutes. What do I need to do to both sides, Brandon?
Divide.
Well, that's what I'm already doing to the variable. In order to isolate it, very good. We're going to multiply both sides by what, Brandon?
-11.
-11. And just to make it easier, I'm going to put it over 1 on this side. I do not have to do that over here. What do we know about multiplicative inverses? What do I know about multiplicative inverses? They cancel out. They leave me with a value of 1, but 1 times m is just m. -11 times -11. What is the value?
Positive 22. 121.
Positive 121. Do you remember at the beginning of the year when we talked about perfect squares?
Yeah.
Is 121 a perfect square?
Yes.
Good. All right, am I finished with this problem?
No.
No, to finish it, what do I have to do?
Check it.
Check it. In order to check it, what property do I use?
Substitution.
Substitution. So I'm going to replace m with what we think the solution is. What do we think its value is?
121.
121. And we're going to ask a question. When we're checking, we follow
PEMDAS.
PEMDAS. Great job. We have no parentheses or exponents in this problem that mean grouping. So mathematically, what do we do first?
Divide.
We're
Divide.
going to divide. I like to change colors here. We're going to divide. We're going to do this part. What is 121 divided by -11?
-11.
-11. If I owe you $11 and I give you 1, what is my balance? Have I paid it in full?
No.
Dylan?
No.
No, I still owe what?
-10.
And if I owe, it's going to be negative. Plus, we do get to use our calculator at this point. Therefore, what is the solution?
M equals
M equals 121.
Very good. You may copy this down, Bubbles.